What's up, guys? In today's episodes, I'm going to deviate a little from the planned sessions because I want to introduce HTTP based JWT authentication. That's because it's very much important for securing our WebSockets. So, what are we going to do is to replace the existing login flow which I had implemented using WebSocket with an Node.js server HTTP1, and what I'm going to do is run that locally for this tutorial series. So this server supports right now sign up, login, and refresh token. If your token gets expired, you can even refresh it. So that's something we'll be using, and we are going to store this locally within the once you receive it, let's say after a login or a sign up, whatever you receive as the WebSocket, the access token, you're going to store it, and then going to make subsequent requests for the WebSocket using this access token. So in this way we can secure our WebSocket communication to an extent. So that's the idea behind creating this HTTP based flow where it's going to return a JWT access token. Um, so if you don't need to worry about this server side much if you are a iOS developer, but if you are actually a stack developer, full stack who takes care of the whole stack, then maybe you need to wait for one of the series I'm creating, just the same stuff where I'm gonna show you how to create this HTTP based Node.js server along with the WebSocket server. So that's pretty much coming up later, maybe after once I'm done with all of this iOS sessions. So let's get started with these episodes where I'm going to modify the existing login flow which I had implemented in the last episodes with this one, which is an HTTP based one, and also I'm going to include a sign up flow along with a logout feature. So the refresh token part is something I'll only do at a later point once we start associating ourselves with, or maybe communicate with the WebSocket. At that part we will start with the refresh token part. So let's get started this one. So the app currently looks like this, where you have the login, which is just having a username and email field, more like a guest user joining, but then I'm going to modify it with having an email and password feature enabled. I'm not supporting guest as yet, but so we'll create JWT auth tokens and then use that to secure our WebSocket. So we'll start by modifying this login flow, plus also introduce that sign up flow which I had talked about. So we need to create one more module for sign up. So let's first start by modifying our login flow. Go to the login screen, and I'm gonna rename some of these things into, I'm gonna add one more field for password. So this is called as username right now. I'm going to remove that and just going to call it as email field instead. Assistant, go there, remove. Instead I'm going to just say it is email text field. Associate that right now. So we already have the email field. Maybe get rid of that, and then maybe we can even get rid of this one. Just call these as password, and then include the outlet password text field, and we also need to make it as a secured field. So let's go there and then make it the secured field. Content type is password and secure text entry, so that whatever you're typing is not visible. So now this is going to trigger some errors. Let's get rid of that. This is going to be, let's just change email password password. Yes, and those two things should So it's asking for a change. Okay, email, password should be fine. Let's go and check. So in the presenter also there are changes because we need to make it as email and password. So some of the validations which we added, we're gonna remove that. This was more an email validation. Let's make it as the empty check itself, similar empty check. So once that check is fine, it's going to enable our login button. It's more like an empty check, nothing more. Maybe we need the email validation here, so we can include that is email here, and then that's it. And the login flow is changing now. I'm just making it as email and password, so it should compile fine. But then we need to disassociate those WebSocket calls which we had integrated for login, which is like this was the call, the login flow in the interactor. So let's go to the interactor I don't think, what is the interactor we had? In the use cases, we had account interactor where we were actually making a call to the WebSocket service. So I'm going to change this. This is where the whole flow was, where we were creating an instance of WebSocket and then doing a login to the WebSocket. So this is what is changing now. Like we are going to implement HTTP based login over here. So let's start by including, once just run this. So now it's showing username and password as the fields required, and if it is valid one, it's going to enable. This is fish, so it's enabling right now. But whatever validation and whatever the call that we are making to the use case has to change. So let's change things around. Email and password are the parameters which we need to accept, and so these changes are what we are going to change. So let's go to the service layer and create a folder for HTTP calls. So I'm going to call it as HTTP. These are some things which I have already done in my earlier VIPER tutorials. I can just give you a link to those the playlist where at least these things are explained in a bit. But then I'm gonna just I'm not gonna copy paste those things, but I'm gonna implement the whole thing. Plus I'm going to also introduce the reactive version of how you can make the HTTP calls. So that is one deviation from the earlier tutorials where we were just doing the normal Alamofire calls using their router pattern. So that is one thing we are going to modify here. So I'm going to have a HTTP service folder, HTTP service, and introduce a couple of files there. One is HTTP service and HTTP router. So this is more like the router pattern of Alamofire. HTTP router, 2 files. So HTTP service is going to accept Alamofire related calls here. So first thing is HTTP service public protocol. So that's my first service protocol creation. It is going to have some functions, at least one function, which is to make a request to Alamofire. So that is being abstracted through this service layer, the HTTP service layer. So I'm gonna include, we already have Alamofire, I'm gonna include a session object, which is an Alamofire session. So this is what we will use to create a session of an Alamofire and then make that request to the server. Also, I'm gonna have a function called request, which is going to accept a URL request, and it is of this specific type URL. It is going to accept URL request convertible type, which is nothing but an Alamofire protocol, which might be implemented by some request object, which we are going to send as a request here. So that's what I'm accepting as a request, convert as a request object, which is whatever implements URL request convertible can be passed here. And the response is going to be an Alamofire data request. This is again a Alamofire related one, where normally if you are using Alamofire, you might just make a call like alamofire.session.request, but we are just maintaining a structure over here. That's only difference. So that's my HTTP service basic structure. And let me now create the HTTP router protocol. HTTP router. Again, let's import Alamofire. Let's keep it public. And HTTP protocol is going to have some basic stuff which is required to finally create an Alamofire request. So that's what we will have here. So I'm going to include all that. First is a base a URL string. So very much required to actually create a URL from the base. If you have, let's say today my base URL is going to be not a server, but whatever is running locally. There is a server which is running locally in my case. So if you can see my terminal, I have one server which is already running. It is accepting many requests. I already tested it. So this is already running in my on the client itself, on my machine itself. So I can at least test these features in a simulator. If I have to connect it to a device or something, then maybe I'll have to deploy it somewhere. So at least for this sake, today I'm not going to deploy it to a Heroku server, but I have a Heroku server where I'll be deploying to actually test future requirements. So first thing is here a base URL string which is going to be my local host pointing to 8080 port or something. That's what is going to be the base URL path. Then I need to have the path, which is nothing but the endpoints which I'm gonna point to, something like a login or sign up, refresh token. These are all my path related things. Third thing which I need is a method, whether the request is going to be get or a post or a put or a delete or even update, anything, patch. So most of the cases we are going to use post or get. So that's how we are going to use it. And then we need headers. Headers are method should be HTTP method, and header should be HTTP headers. It's nothing but a key value. Accepts Alamofire header dictionary. It's just accepting key values of headers. Headers can be most of the in our case we might pass a bearer token. We might also pass a content type application JSON as within the headers. So this is one of the parameters. I'm keeping it optional, but it's most of the case in our server, at least it is mandatory that we need to pass at least the content type application JSON as the header value. And then you need to have, if you need to pass parameters like whatever, if you need to pass something through the query itself as a query string, that is what is you will pass through these parameters. In our case, I don't think we are yet there. My server, at least I don't have anything right now where I'm passing something through the parameter. So most of the things are going through the headers. So let's see that once we reach there, if something is there, we might use that. And then we need a function. We are going to use a function body which will actually create your body, which needs to be passed. So whatever this does is it accepts some model or something, or even a dictionary, and then converts or translate that into a data. which is what we will send to the server. So that's the idea behind this body function. So that's done. Now we need to we need something called a function called request also here, because it is going to use the same service which we created here. So this router is going to consume a service which might be implementing this HTTP service protocol. So we might have different services. Let's say for chat room there might be a service for user account creation, like login or create an account. All that we might require an account HTTP router which will be implemented which might be implemented by our HTTP router. So that's what. So every router needs to make a request using a service. That's what this accept, using service. Okay, let's keep it as using HTTP service. So it whatever conforms to HTTP service can be passed to this function, and this in turn creates a data request as a response. Data request, this is what you will use to make a request, and it returns a type of data request. So this is our whole. So throws is because when you are accepting, there are some of the things which can throw, like body itself. I'll show you once we reach there, because that is what we are keeping some of the function as throws, because those function can throw some error. So that's what I have kept some of the things. So this is a basic structure for a router pattern in Alamofire. It's been discussed in many other of my tutorials, earlier ones. If you need, I can include that playlist where it is basic request response using Alamofire. But here I'm going to deviate a little, because I'm going to use RX Alamofire as well, so that we can make it purely reactive. So I'm going to import. Okay, first thing, let's extend these. Some of the basic things we can keep within the router's extension itself, so that it does not ask all of the things to be implemented wherever you create a router. Let's say I'm gonna right now create an account HTTP router, so that's going to implement this HTTP router. So before that, let's extend some of the things and keep those as null. So parameters, I don't have any parameters to be passed, so I'm going to keep that as parameters. I don't need to implement this right away. Instead, I'm just going to keep it as a default nil value. I'm going to pass. Then body, I'm going to keep nil. It's more or less like wherever I need it, I can extend it and create that body part. So data, and it's also going to return nil. Then I can keep some of the things. Okay, function body throws data, return nil, and some of the things like we have a function. I'm going to create a function which will be used within any of the routers that you are creating. Let's say the account HTTP router which we are creating is going to use a function. So I'm not going to expose it outside of this protocol. I'm just going to use it within here itself. It's going to be called as URL request. So this is something which will create a URL request for you. So its return type is going to be a URL request. So it's going to use many of the parameters which are defined already here to create a URL request. So what all might be required to create a URL request? You might require a base URL for sure. Then you need the path. So both of these combined together, you will create a request, and also the method which you need to pass, and maybe the headers as well. So these are the 4 things I'm going to use to create a URL request here. So I'm going to use that where URL is going to be from, I'm going to create that base. You already have this base URL string. I'm going to convert that to URL. as I'm gonna convert it as a URL. So this is the reason it's already saying throws. So this is the reason this is already saying throws. So one reason I can keep this as a throws function. So we know that this function can throw an error, so that I can keep it within a try. So that's done. So as soon as there is an error, you can this function is expected to throw an error which can be captured somewhere else where you are using this function. So that's the reason you're keeping it as a throws function. So that's done. So you have the URL. Now you can append the path component, which you already have the path here. So you can just say path. So in my case, it's going to be localhost 8080/API is the base URL, and then path can be different based on the use case. Let's say if it is login, path can be /login. If it is sign up, it can be /sign up, something like that. So that's what we are appending here. And then let's create that request using this URL request, this URL which we created. So that will be URL request passing URL. So it is of type URL convertible. So this is my URL. Method is whatever we are defining here. We can accept that method. Headers, again, whatever we are accepting, those are my headers. And that's it. That creates I guess I also need to associate a body to this. So this is my header. It's again throws type, so I'm just going to keep it within a try. This is where, because I also need to associate the body dot http body. If I need to, then I can just say, I can just call this function body function. Again, that will be a throws call to throw, but it's not marked with try. So I'm again marking it with a try. So finally body is associated. Now I can just return this request. So the whole of this process is being abstracted within this protocol. So later when we create this HTTP router based subclasses, or whatever implements this HTTP router, might just call this function, and internally it's going to generate this URL request for it. So that's why we are keeping it within this abstract layer, which is our protocol. So that's done. Our request, our URL request is ready, and I'm going to also create the request function here. Function request. We already have this function request. Whatever we have here, we're gonna keep it within the extension also as a default one. So we can just say return it's accepting an HTTP service. So once an HTTP service is accepted, we can just create the request using request convertible. So this is URL request is actually implementing URL request convertible, and even our request which we created within the HTTP service, we kept it as URL request convertible, which is nothing but a protocol. So URL request is something which implements that. So that's the reason we can just pass that whatever you have as a function here, we can just call it as URL request. We already have a throws for this as well, because this throws, it gets propagated to even this. If you don't have it, it's going to say this one throws. So we can just say throws. We can maybe handle it at some other place. Call to throw. So again, we need to call try here. It just delegates this error handling somewhere else. So our request part is also ready. This is my router. This is the router Alamofire's router pattern, where we have implemented all the things required to create a service and to make a request to Alamofire using a service. So router, the usage is pretty simple. Once we are done with this, we'll create the account router, where we are gonna create the paths where we need to make the calls like login, sign up, and everything. So this is done. all that we need to do is, as I was saying, we need Alamofire as a dependency. So are these already added? Let me just go to, let's connect service. See, it's not added, so I'm gonna add these two right now. Add frameworks. I don't think we have Alamofire in this project. I need to check that. I'm not included. Okay, Alamofire is already there, but I have not included it in Carthage. I'll just show you. It might just give me an error once I have. I'm just gonna include it right now because it's already available, but let me just check once whether it's there in my Carthage cart file. So it's not, Alamofire is already there in it's not there. So we need it's shown in my version because I had already worked on this code base, so I had included it within a different branch. So once I moved back to the main branch where I am showing this tutorial, this is not added yet. So Alamofire, it's going to give me errors. So let's do one thing. Let's include Alamofire references required, whatever I have in my working project. I'm going to include those two within Alamofire. So these are the two dependencies. Alamofire 5.2 is what I'm going to use along with RX Alamofire. So cancel, I'm going to include it and then go to my project location. I'm already there right now. So all that I need to do is Carthage update platform iOS. This might take a while. I'm just going to do that. Because it's already there in the cache, maybe it's going to get done faster than normal, I think. So it's picking up Alamofire, yeah. So once this is done, we need to include these paths in the project location. Otherwise, it's going to crash the app saying the image is not found. So we'll also do that. So once this is getting completed, let's do that because I already have a reference project where I can pick those values which we need to include. So build faces, Alamofire, gonna come here. Let's connect target, build faces, Carthage, add Alamofire and RX Alamofire. RX Alamofire is nothing but a wrapper of observable around your normal Alamofire. So whatever request that you're making using, let's say, normal Alamofire session manager dot request just becomes like Alamofire session manager dot RX dot request. That's only difference. So it becomes reactive. Come on. And RX Alamofire. That's included. And it's still building. I guess again it's gonna take a little while. So Carthage update is done. So let's go back to our project. You can see RX Alamofire is included along with Alamofire. It's giving one error. Let's see what's that. Username. Okay, so this is what we are going to change. Let's let that be there because we are just going to focus on this one right now where we created the HTTP router and wanted to create an extension to it so that it becomes reactive. So first thing first, let's complete this HTTP service part where we need to create a reactive extension to that. First thing, it's nothing like very difficult to understand, but then if you're already following reactive programming, then if you want to create, let's say, make something as reactive where you can associate, let's say, something like here in this case you have a text field or something, text field dot rx dot text. If a normal text becomes reactive when you, let's say, access that rx part in it, and then you can that becomes an observable type. So it's a similar thing is what we are trying to do here, where we are going to convert this http service into an rx version. So for that, let's call these as reactive http service, and that has to implement something. So for that, let's include rx-swift first, and then we just need to say okay, first thing is http service is what we should become reactive, and for that to become reactive, what we need is a reactive extension. So we need to make it reactive compatible. So that's the only implementation that you need to make it reactive. So what are we trying to make reactive here? It is actually this request. So for that, let's create an extension of reactive http service, and we'll create a function, request function here like this, and then we need to return a data request type. So one thing that we did here is we need to include Alamofire as well, rx Alamofire as well, so that you can access that rx part of the session. So for that, we already, so how do we access this http service from reactive http service? That can happen using something called as a base. Reactive http service. So this is not complete yet. This extension is not an extension on reactive http service. It should be an extension on reactive, which is something coming from rx Swift. It's a protocol reactive. You need to extend that, and then you need to say what is going to be the base to it. Base is going to be reactive http service. So how can you access this request from within this extension rx reactive? So that can happen using the key base. Base is nothing but whatever you are associating here. So reactive http service in turn is implementing http service, so you can access this request. You just need to call base.request and pass a URL request. So this is again accepting a URL request. You just pass that URL you need to this is a regular approach. I just got it wrong. So this is your regular approach if you are, let's say, just using an http service. But if you are using, let's say, a reactive version of it, you don't need to actually worry about this one. This is something we used in the earlier tutorial series, where I was just directly using this react request. But right now, whatever we are trying to do is to create a reactive version of this request. So for that, I am accessing this session of this base, and then using that, I'm going to create a request. So it is accepting a URL request convertible. So this is what I'll pass here. So this is the regular version, but if you want to make this request reactive, and one more other thing is this request should return, because we are creating a reactive extension, it's not returning a data request, but it should return an observable type so that it becomes reactive. So for this to be an observable type, I cannot directly call the sessions request, but I'm going to call rx, which is coming through this. It's already rx Alamofire is a wrapper around on Alamofire with the observable types, which is rx Swift. So that is what we are going to use here, and then I'm going to make a request so that this returns an observable type of request. It feels a little complicated, just because if you are not comfortable with reactive programming, it might feel a little complicated. So it's nothing here. You can ignore this one. This is a normal approach where if you are making a request to Alamofire without reactive programming, then you need to use this. But if you want a reactive extension where everything is going to request is going to come back in a reactive way, it's nothing like even in earlier tutorial episodes I have shown how to send back a response in a reactive way. There whatever we do is you create a observable type and then start sending it through that on next and on error or something. If there is an error, on next, on completed, or even you create a single, but that is already taken care by Rx Alamofire. So if you did not have an Alamofire, let's say in this case what I would have done is I would have returned an observable dot create, which creates an observable for me, and whatever I create as a request here, I would have just sent it through, let's say if I did not have this Rx, I would have just created the URL request like this, and I would have just sent it like observable dot or whatever this observable dot on next, this one, the request whatever is created, and then I would have said observable dot on completed, because my work is completed. I just wanted to create an observable here. Paste you need to reference. So this is what I wanted to show. Missing return. Okay, needs a disposable. Okay, so idea is that return observables dot Rx Swift disposed. Okay, disposables dot create, because it needs a disposable type, so it should compile fine now. So this is now how we are converting a regular request to an observable request. So internally whatever we are doing here is already taken care by Rx Alamofire. So all that we will have to do now is that we can just return something like you already access the base, which is this HTTP service dot, you just say Rx, because whatever we are doing here is already taken care by Alamofire, Rx Alamofire. So we just get the access to base dot session dot Rx dot request, which will accept URL convertible. So you can just pass this URL request here, and it is already of type observable dot data request. So this is how you are now. This was the Rx version of session, but whatever we need is to convert our function, the request function which we created, to reactive version, which internally will call the Rx version of the Alamofire. So I guess this is understood, because it's a simple concept how to make your let's say you already have a protocol. How do you make a reactive function out of that protocol functions, something like that. So similar thing we are going to do. So this is complete. You have a reactive function called request available right now. So let's say if you have this service created somewhere, I'll show you that later, or you can call the Rx dot this request function from there. Let's do the same for the router as well, because this also needs a reactive extension. So I'm gonna create another protocol called it's reactive HTTP router, which is going to implement first thing is HTTP router and reactive compatible. Reactive compatible not there because we don't have an import of Rx Swift. reactive compatible. So that is my basic structure. So here again we are going to have a reactive version of this request. So internally it's going to call, we already created that RX version of HTTP service, so it's going to consume that right now. So I guess this should be okay, this is fine. So now I'm going to create an extension for reactive. This is a regular approach for creating any kind of reactive properties or events or anything, like a control event or something, which we normally do. Let's say if you create a custom control, you want an extension, you want that custom control to be reactive. We have done it in a lot of other episodes where we have created custom controls. Even in this series, there is a scenario where we are going to have a chat text field, or a text area and a button. So you're combining that together and making a single control and making it reactive. So on tap of that chat button, send button, you're gonna receive a reactive version of an observable which will contain whatever you are sending. So it's very interesting. I'll show you once we reach there, where base is reactive HTTP base is reactive HTTP router, and let's create a request object, request function for that. Similar thing, function and function request. It should be, I'm making it a generic function, T, where T is okay, let's call it service, where service is going to be of type reactive HTTP service. Generic function which will accept a service, and it's going to be of type this service which we define now. And the response is going to be, again, this is data request, but we need to send it back as a data request object. So it's pretty simple. Now all that you need, you already have the service. All that you need to do is return service dot rx dot service dot rx dot request. Why is the request not available? Reactive HTTP service. So this request has to be, let's check once. Okay, we need to access it. Okay, it's already a service. Reactive extension. Let's see what's, it should give an error. Okay, missing argument. It's asking for URL request convertible. So all that you need to call is, because this is the router, you need you know what we need to create. You just need to call base dot as URL request, because this is again similar to what we did here. This is for the regular way, where if you wanted to create a request, then all that you did is not here. If you were in the router, we created a request, a regular request accepting an HTTP service and returning an observable of returning a data request. Regular approach where we just called the HTTP service dot request and just accepted the URL request. But in this case, it's going to be the reactive one. So all that we do is we accept the service. We already implemented the RX version, accepting the request accepting a base URL. So this one, Similar to this, we are calling this from the base, we are calling as URL request. So this created a request. Now it's giving me an error. So I can always say, similar to this throws, I can include a throws for this as well, and just say try. I guess that's it. This is my observable version. So if there is an error, it's going to try throw that somewhere. So this will be used for regular non-RX version. This will be used for the RX version. So that's how you implement a reactive version of the service as well as a router. You can use this approach in creating any kind of reactive object. If you know, if all that you need to do is import RX Swift, create an extension reactive, and point which is the base on which you are creating that reactive extension. In this case, it was reactive HTTP router. We created a function similar to this, made this function more reactive, where it is going to return an observable type instead of a regular data request. That's what it is here. Now we are ready with the router and the service. All that we need to now do is to use these two in when you create, let's say, an account service right now, and an account router and a service related. So that's what we are going to do right now. Use these, consume these two. Let's get started with that.